So I'll try and do my very best to keep you awake through the next hour. Welcome to Black Hat, welcome to Stegospolit. My name is Saumil Shah. I will be showing you a few tricks that I put together of my own. Before that, a couple of things. You must be wondering what the hell is this tiger doing on the screen. Well, it is, I got to give you a little bit of a background to it. It is, for us, this is the festival of Diwali. Yesterday was Diwali. All of India celebrated it. Today is Gujarati New Year. So shout out to all my Indian friends. Wish you a happy Diwali and a prosperous New Year. Wish you all a happy Diwali. One of the traditions on Diwali, instead of firecrackers and all, we make paintings using sand, colored sand. So this is a colored sand painting that me and my family did a few years ago. Because my talk is about pictures and colorful pictures, I said, why not? Let's present it on Diwali. And this year, this is the Rangoli, the sand painting that we did. Because I was presenting in Holland, and as a tribute to MC Escher, this is titled Escher's Elephants. And this is sitting in the entrance of our house, like this, to greet everyone. It was a mathematical nightmare and an artistic nightmare to pull off, but we did it. So that's it. Happy Diwali. Welcome, everyone. My name is Saumil Shah. I've been doing Black Hat and InfoSec for a very long time. I'll give you an example. I was here for the first time in 2001 at the Grand Hotel Krasnopolsky with a few good friends like Grifter and Jeff Moss and a lot of others who we used to hang out and party and occasionally get up on stage and say a few things. I don't have much research that I do these days. I just train and teach people how to break browsers, but there are times when I put together a few things over the past years, and that's what led me to Stegospolit. I first talked about Stegospolit in May, in Amsterdam as well, and that led to a lot of controversy. A lot of people started saying a lot of different things. And then I told them that, okay, unfortunately, nobody can be told what Stegospolit is. You got to see it for yourself. I don't have the Morpheus slide over here. But it has been called a pixel virus. It has been called pictures that can hack your computer. Let me set the context straight, what it is. Let me show you what the tools do and what the technique is. I want to kind of give you an agenda of what I'm going to talk about. We're going to see new techniques on exploit delivery. We are not talking about zero-day. This is not a new browser exploit. These are not bugs in image encoders. These are not bugs in JPEG libraries or PNG libraries. This is just a way of delivering exploits with style. You can deliver an entire browser exploit encoded as pixels in a popular image format of your choice. I've been working on this for 4 years. My first experiments have been with GIF and BMP. And last year I had a few breakthroughs with JPEGs, especially overcoming lossy encoding and PNGs. All this was done sitting at the hackerspace in Luxembourg. Last year on Diwali day, because I could not fly, there was like some flight blockage. So I had 2 extra days in Luxembourg, wrote up Stegospolit. Okay, so what is Stegospolit? Stegospolit is not a zero-day attack with a cute logo, although I have a cute logo for it. It is not exploit code hidden in EXIF. It is not cross-site scripting via EXIF, not PHP shell uploads via EXIF or PNGs. It is definitely not a new cross-site scripting vector. What it is browser exploits delivered as pictures. The takeaway from this discussion is I want to show you the next wave of exploit delivery coming up. I'm talking about Stegospolit in public. I'm not the only guy who has probably pulled this off. There are several others who may have pulled this off, except for the fact that they're not talking. One day we're going to see these attacks in the wild. The problem with these attacks is they just get mistaken for being plain innocent pictures. You're never going to put a second thought towards pictures being malicious. They will escape under the radar, undetected, until they go to their destination, and then they own you. So the purpose of my talk is to make you aware of this technique. Also to raise some questions is, okay, what are we going to do about this? What are the next step of defenses coming in? But first, let's see the technique. So like I say, a good exploit is one that is delivered in style. what does it take to deliver an exploit in style? So here are the few assumptions about Stegospolit. First, we only want image traffic or image data. Exploits will not travel by themselves. The only things you're going to see on the wire and disk are valid images. If you run tools on them, they will tell you, yes, this is a valid image. All image data will be perfectly intact. The browser exploit code will be hidden, encoded in the pixels of the image. This is where the steganography comes in. When you encode something, you've got to decode it. So we have to have a decoder written in JavaScript so that it can decode the pixels back. But the decoder is also embedded in the same image. So now your container contains two things, image plus decoder as a valid image. And this is where we're getting into the concept of polyglots. Then, when the image is delivered to the browser, it will be triggered automatically upon loading, all with just one image. So this is the background of Stegospolit. There are tools written, simple tools in HTML and JavaScript and a little bit of Perl. I will show you the tools with a demo. So let's just get to the basic concepts first. I talked about two things. Steganography, which is the art of camouflage. You hide something so cleverly that you don't notice it. And then we talk about polyglots, again a tribute to my favorite artist, MC Escher, who I absolutely adore. What is a polyglot? It is two or more data formats in a single container that coexist without breaking each other's syntax. Now, how do we do this together? So far, whenever you've had an exploit, especially a drive-by browser exploit, it comes heavily obfuscated with JavaScript and there's redirects and all that stuff. Eventually, what happens is you load a URL in a browser, so a lot of redirects happen, obfuscated JavaScript gets landed in your browser, executes, use after free or whatever it is, detonates the payload, and there you're owned. Let us take this simple concept and, if my clicker works actually. So, here. We have exploit. I'm going to take two case studies, one with an IE use after free and the other time permitting with a Firefox use after free. And I'm going to demonstrate this on JPEG and PNG, so give you an idea of, this is possible with different images as well. So instead of sending the exploit code directly to the browser, we're going to take an image, any image, then we're going to encode all the pixels and get a encoded image with the exploit code embedded in it. But it's so well done that you can't see the pixels. Then we got to take the decoder script and pack it within the image itself, turning the image into a polyglot. This technique is called images. I gave it that name because it is image plus JavaScript. And then you deliver this polyglot to the browser. This polyglot will not be detected. I have done some tests to prove that. So a quick introduction to the tools. For doing this, we have the Stegospolit Toolkit, which is distributed freely. I'll tell you where to get it from. So we have the Stego tools. The steganography that I'm using is very rudimentary. In fact, it's a joke. It's not sophisticated at all. I am not a steganography guy. I just figured out how to hide pixels in images without them being seen. Part of the reason I like doing this is because I'm also a photographer and I love studying JPEGs very closely. And if I can't detect aberrations, that's good enough for me. So there's tools all written in HTML for encoding the pixels. Then there's polyglot tools for combining the decoders within the encoded image. And then, of course, I have some sample exploits to do the demos. I'm going to do a CVE 2014-0282 demo with Stegospolit. Right, so let's get to the nitty-gritties of things. I'll show you how to pack an exploit in an image and then make it into a polyglot and deliver it and do the demo. Before packing the exploit in the image, I'll also show you how an image really works. So let's first check out how images work and how all this is done. So give me a moment. Okay, just want to make sure I don't lose my notes. Okay, so think of an image composed as an array of pixels. Now, what is a pixel? It is nothing but an 8-bit value or a 24-bit value which represents either grayscale or RGB color. And these are packed sequentially in a matrix to give you an image. What we're going to do is we're going to take every alternate pixel or every third pixel or every fourth pixel and encode a bit on it at the least significant layer or second layer or third layer. And I'll show you how this whole game works, how to think of images in layers. So effectively what you've got is you're preparing an image, you take an ASCII stream, turn it into a bit stream. For every bit, you apply them on pixels. Just change the value a little bit, you won't notice it. Of course, here I've exaggerated it a little bit. But once you've packed it really finely, there's no way to tell what's been packed over here. So what we're going to do is we're going to take this image and we're going to take this exploit. This is CV 2014-0282. This is all JavaScript code with return-oriented programming, shell code, and all that fun stuff in there. And we're going to pack this JavaScript code onto this particular image. Whenever you have an image, think of an image as several layers of pixels, 8 layers of pixels to be exact, like transparency stacked on one another. If I were to decompose this image into its bit layers, each pixel can take on 8-bit values. The least significant bit is layer 0. The most significant bit is layer 7. So if you just strip off different significant bits and prepare an array of them, then your image can be represented as a set of 8 layers. The topmost layer contributes maximum to the shape of the image. The bottommost layer contributes maximum to the details of the image. So if I were to split them up, it'll look like this. This is bit layer 7, bit layer 6, 5, 4, 3, 2, 1, and bit layer 0 basically appears just as noise. If you composite all of them together, you get the resultant image on the left-hand side. Now, this gives you an idea of where to hide your data. So let me just show you how it works. Here's your image. If we just start stacking the different layers, this is bit layer 0. We just see grains. On top of it, you layer bit layer 1 and bit layer 2, 3, 4, 5, 6, 7, and that's the composite image. So what we're going to do when it comes to encoding, we're going to start writing our exploit code on any one of these layers. Let us see how to do this. So let me show you some tools. And then, so here we are. I never do videos of my demos. I always believe in live demos, which has the added risk of them blowing up in my face and making me look stupid. But I will not learn. I will still do live demos because they're cool. Okay. So let me first just show you the image layers. Here we go, image layer analysis. All these tools are written in very simple HTML and JavaScript. So I'm going to just load up this JPEG file. Expand the view here. And down here, I've got a little layer view. So if you see on this side, I am directionally challenged, so I don't know what the hell is left and right. I'll just say it's this side. So if you see that side, you can see this is bit layer 7. I don't know how to stretch this out, but let me show you what happens if you go down the bit layers a little bit. So if you go down to bit layer 6, you start seeing more details, less shape. 5, 4, 3, 2, 1. And at bit layer 0, you basically have just jagged pixels. And if you start overlaying them, one on top of each other, you start getting a good composite image. And that's the full image. Okay. Now let us see how the encoding is done. We're now going to take a bit stream, which is exploit code, and encode it on these pixels one after the other. So load this image again. Now we will choose which layer to encode it on. We have 8 layers to play with. If we encode it on the topmost layer, and so I just say this is at layer 7, encoding is, Anyway, encoding is at layer 7 and the grid is 3 pixels. So every 3 by 3 pixels there'll be a bit encoded to spread it out a bit. And then I'm going to choose an exploit. So this is the exploit that I'm going to encode on. All this JavaScript stuff written over here. And we just say process, like a dark room. So here you have it. You have a mouse pointer, yeah. So if you see the resultant image, you can notice a lot of pixel aberration because we've written on the topmost page. That's going to be the most visible. It contributes most to the entropy of the image. Now, if we just change this and instead say, okay, let's encode at layer 2, a bit deeper down. Now you don't see anything. The encoding is still there, but all the pixels are absolutely hidden away. You can't make out there's any aberration whatsoever. So this is the very primitive form of steganography that I've got. Now comes the step of processing it into a JPEG file, and this is a little complex. The reason why JPEG is complex is because you lose data. Yeah. So we did the encoding at 7. Now we did the encoding at 2. I just showed you this, so we don't need to do this again. And when you magnify the encoding at bit layer 2, you don't see any aberration at all. Now, when it comes to encoding on JPEG, the problem is JPEG is lossy compression. You lose pixel data. Pixels get approximated to their nearest neighbors. And this is not good for exploit delivery. If your exploit code gets disturbed, the bits of your exploit code are lost, it's not going to work. So how do you ensure that after making it a JPEG, you get complete reconstruction of the exploit code? These pixels are not disturbed. So I went on the wrong tangent, of course, tried to make things too complex, studied the discrete cosine transform, and tried to tweak the DCT table so it won't affect the 8th corner pixels and whatnot. Then I said, oh, this is not working, this is too complex, screw it. Then I had the brainwave at the hackerspace in Luxembourg saying, okay, you know what, if you encode it for the first time, maybe 50% of the pixels are valid, 50% fall off. Take what is remaining and encode on top of it, iteratively, until it converges. Every iteration, the error is minimized, and the pixels end up being stuck. After 9 or 10 iterations, you get a fully processed JPEG with all the pixels on it. And that is what led to iterative encoding. I say the necessity is the mother of invention. So whatever works is good. let me show you a demo of iterative encoding. We're going to encode that use after free exploit on the Ganesha image using iterative encoding. Right, so here it is loaded. We're going to encode on bit layer 2 with a grid of 3. These other options, the RGB options, are when you're dealing with color images. I chose a demo in black and white because it's simpler to explain, because with RGB I have to explain the red channel, green channel, and blue channel. It just makes it better to hide pixels if you've got 3 channels instead of 1. It takes a little more time, which I don't have right now. So here we are. Get the exploit. Now I'll show you how this works. The first thing we're going to do is just layer it on over here. Now how does this encoding work technically? I'm not using any JPEG library to do the encoding. I'm just using HTML Canvas in the browser. The browser itself encodes, and if the browser can encode it, the browser can decode it, again using HTML Canvas and JavaScript. So this ensures that when I deliver the exploit, it will be successfully decoded with the JavaScript that I've used. And here is the encoding section. My UI work is very poor because I'm an awful designer. I may be a decent artist, but I'm a very poor designer in terms of interface. When I do the encoding, keep your eye on this side of the screen, whatever that side is, and keep your eye on the red pixels which show the errors. So I'm going to click on iterate. It's going to do the first iteration, and you can see that the number of red pixels is decreasing with every pass. This means that with every encoding, the pixels are getting stuck properly, and the last iteration, it succeeded. And when I have the output, it says pass number 9. There is a little bit of error. There is about like 45 out of 480,000 pixels which were still improper, but they do not affect our exploit. They're somewhere in the middle. So when I decode it back, the decoded text works okay, and the MD5 checksum also checks out. Please do not chastise me for using MD5. Okay. I didn't have the SHA-1 JavaScript code, and I was too lazy to write it. So now we have a perfectly encoded JPEG file with the exploit code in it, so that you just can't see it at all. And let me open it up in the encoder, in the analyzer, to show you the difference. If we peel away the layers, we will be able to see it, but on the front of it, you can't see anything. So here is the resultant image. Now, I've encoded it at bit layer 2. So let me click on bit layer 2 and show you how it looks like in the encoded version versus let me show you how it looks like in the original version. So here is the original version. If you see the window area, it's all black. If you see the encoded version, the window area has some disturbance. This is at bit layer 2, these are the pixels of your exploit code. But when you composite that, you just don't see anything at all. Now, the encoding is done. There's a little bit of JPEG and PNG stuff which I'll come to in a little bit. Let's talk about how this is going to be decoded. This has to be decoded in the browser. So the decoder code has to be JavaScript. I want to keep the decoder code as simple as possible and as innocent as possible, so that the decoder code itself does not get picked up as being something malicious. So the decoder code contains only canvas read information and arrays, and just bit shift operators and binary bitwise operators and whatnot. It does not even contain a single eval. I have another trick for that. So HTML5 Canvas helps us do this. We can read the image pixel data from the JavaScript, rebuild the exploit code, and then trigger it. And here is the decoder. Last year when I did it, the decoder was about like 1500 bytes. Now I've got it shrunk down to 651 bytes using really compact and really ugly JavaScript, but it works very well. It's perfectly innocent. You don't see eval anywhere in here. The way I'm doing eval is like this: set timeout new function x. So you create a function out of a string, and a function constructor will give you a new function object. You just trigger it after a little timeout of 99 milliseconds. If you're still worried about this being detected, then you can JJ encode it, which will encode everything into non-alphanumeric JavaScript, and this will even sneak through. Okay, now comes the part of packing this JavaScript into the image itself, creating a polyglot. Because I said, if you want to exploit in style, you got to do it with just one image. So we're going to create images that auto-run. How does this work? This is a technique called images, which is a combination of image and JavaScript. So on one hand, if you look at it in an image context, you see pixels. If you get this injected in the JavaScript interpreter, it will run as code. And this is what we call as a polyglot. So the same container, if viewed in a frame buffer as an image, if run in a JavaScript interpreter, is code. Now how does that happen? First we'll see how to pull this off with JPEG. This led me to an interesting discovery with file formats. You study a file format, the more popular the file format, the more extensible it is, or rather the other way around. If a file format is extensible, it becomes popular and survives the test of time. People keep using it. If it is too locked down, people don't use it much. JPEG has survived over decades, and new additions are being made to JPEG as well. When a file format is extensible, it's basically following Postel's law, that be generous in what you receive and be very, very conservative in what you give out. Which means that a JPEG interpreter will basically parse anything given to it. If it doesn't know how to parse certain sections, it will ignore them. And this is where the concept of polyglot comes in very handy. We will just pack extra data into a JPEG file following the JPEG format, which doesn't disturb it, doesn't alter its syntax, but when the interpreter looks at it, it's just going to ignore it. So here's the recipe for images with JPEG. Now every JPEG file has various markers. You have something called start of image, which is always FFD8. Then you have the app0 marker, which is FFE0. And then you have a 2-byte length with JFIF0. This basically declares it's a JPEG file. Then you have a major version, minor version. You have the X resolution, Y resolution. And then you have the other markers, which is this is the quantization tables and the DCT tables. And then you have a start of frame, the compressed pixel code. So this is what creates a JPEG file. What we're going to do is very simply play around with the length. If I just increase the length to say 12,000 bytes, then I get a whole lot of extra space in the app0 marker, which I can use at will. And in here, I'm going to pack in HTML code. So I'm going to have an open HTML tag, then a whole lot of random bullshit because HTML will ignore invalid attributes. The browser will still not care. So the random stuff is just to spread it about so that signature engines can't pick it up. Then you have the header, the decoder JavaScript, and everything goes here. At the very end, I just put script type equals text undefined, which is like everything terminates. The rest of the JPEG file will be treated as JavaScript and be passed to an invalid interpreter, which means it will do nothing. It just sit there without complaining. And here's the rest of the JavaScript. So this is how you create the whole polyglot. Let's do this and then test it out. So let me get the okay. So I have to so here's the HTML code that I'm going to inject. I've just written a little template where everything written with hash random hash gets substituted with randomly generated data. So you have random, and then you have some style sheets, and you have some JavaScript over here. This is where the decoder script will go, and this code and the decoder script will get embedded in the polyglot. Here is the decoder script, and this is exactly what I showed you on the slide. So let us combine them. Hang on, I'm just going to use the history because turning around is yeah, here it is. So I'm combining the template and the decoder script and generating a polyglot out of it. It's called Ganesha's input Meterpreter. The exploit code I've put in is a reverse Meterpreter shell, which will, when you open the exploit, it'll give me a Meterpreter shell. And then I have a Meterpreter script to upload a privilege escalation exploit, get system, and own the whole computer, take a screenshot, and take a list of processes and everything. So all weaponized. So here we are. This is Stegospolit images. It has basically created a new JPEG. Let me show you what that looks like. So here's the resultant JPEG. You see a little HTML marker over here. I'm still working on how to smoothen that out. And down below with all the random stuff, at some point you will see this JavaScript in the app0 marker. It's not going to affect the JPEG code because if I just do open on this, I'll get this opened in preview.app. So this is a valid JPEG file. If I do a info on it, it'll tell me that, yeah, this is the 800 by 600 JPEG and all the other stuff that goes with it. So it's not destroyed the format at all. It's just preserved it. The extra data has just snuck into it. If you're really paranoid and you want to JJ encode this, then here is the JJ encoded where you don't see any of the script data. Instead, you just see symbols and non-alphanumeric stuff. There it is. It just scrolled up here. This is all the JJ encoded stuff. Again, you can put emoji in it, and you can put all sorts of weird characters in it and make it sail through. All right. Now let's see how this delivery is done. Let's see the rest of the demo. So on one side, I have Metasploit ready to go to catch the shell. And let me keep it positioned here. Close the browser. Okay. So we'll keep the task manager on. Let me now load this image as is in the browser. So it's a direct link to the image. Let's say this image is uploaded on some web server somewhere, and you give a direct link to the URL. You open the image, and this is the image being opened. You see the image as is. There's no aberration in this image whatsoever. However, you think you're seeing an image, you're really seeing a valid HTML file. The HTML file has an image tag in it which says image source equals to hash, which displays itself back as an image. So that is the beauty of the polyglot. You don't see anything strange with it. I have programmed it to trigger upon on mouse click. So if I click anywhere in this image, it's going to trigger the exploit. The exploit is going to do a heap spray, fill up the heap, and then do the use after free, and get the return-oriented programming code and give you a shell. Interesting side note, heap sprays are also being detected these days in browsers. If you try to consume too much memory repeatedly, using JavaScript it gets detected. So I use HTML5 Canvas to do heap sprays as well. So the ROP code gets sprayed as pixels, and that's why I had the CSS to hide all that stuff. You don't see it. You'll see the CPU spike up for a while, and because the HTML5 heap spray is a little slow, it'll spike up for a few seconds, and then when it's done, you should see a Meterpreter shell popping up in this window. Where did that go? Oh, there it is. The shell's right here. Here we are. So Meterpreter is executing. It's doing the migrate. It's going to do, there goes a browser. It's going to do the privilege escalation, run mimikatz, get all the passwords, get everything, upload a screenshot back onto its desktop. And at this point, well, this guy is owned. Let me get a shell. Yep. And I'm in the authority system. So at this point, the image is detonated, the exploit, browser is owned, game over. Thank you. We have about, 20 minutes, give or take? Yes. Okay, great, excellent. Then I can show off the PNG stuff as well. I just wanted to make sure this demo worked. The PNG demo is a little flaky, not because of my PNG skills are weak or my Stego skills are weak, because my exploit dev skills are weak, and that use after free, I haven't gotten it to stabilize really well. So yeah, if Halvar Flak is here, then he can probably point out where I suck. But if not, we'll just try it 3 times and hope it works once. And then you're just got to believe me that it works. Okay, let me clean up the processes and get ready for the PNG version. With PNG, it's the same thing, except you get a much better method of encoding data. PNG is lossless. There's no pixel approximation going on. So you can encode at layer 0, which is the lowest bit layer. In JPEG, if you encode at layer 0, the errors are so much that the data just gets wiped out and you don't get convergence of the encoded data. With PNG, you get full convergence and you don't lose any data. And it works across all browsers at once. So with PNG, the way you want to do it is, you have a PNG header with this PNG data, and everything is in what is called as 4cc chunks. 4cc is a generic method of representing multimedia data, which is used in AVI files, MPEG files, PNG files. All the chunks are prefixed with a length and then a 4-character code. That's the name. 4cc comes from 4-character code. The 4-character code tells you what type of a chunk this is. So this is an I header, IDAT, IEnd, and any image format can define their own 4cc chunks. It's a very beautiful extensible format. So then you have the 4-character chunk, then you have the chunk data, and a CRC at the end to make sure that the chunk is intact. So here, we then create a text chunk, which is actually a valid chunk. And in the text chunk, we can put our HTML code right in here and apply the correct CRC. and then you have the rest of the image data that follows. And this is how you encode PNG. I've written a full paper on this. It's on a website called Stegospolit.info. This gives you the whole mechanism of how it's done, the rationales of how I did things that way. You can read it at leisure. It's in the slides as well. But let me now show you the PNG demo. We'll do this using Firefox. So I already have the thing encoded, so I'm not going to do the full encoding again. But I'll show you an encoded image already here. There's also a use after free bug in Firefox. Here is the image, and the data has been encoded at bit layer 0. So let me switch on bit layer 0. Somehow it's not working in here. Note this. Oh yeah, it's working, except it's on this side where we can't see it. Let me click on bit layer 0, and this is how bit layer 0 looks like. And let me turn on just the green channel, because that's where the exploit is encoded. So if you, oops. If you look at this part of the screen, I'm asking you to have very sharp eyes all the way at the back. But here is the exploit bits. You can see a little bit of it is encoded over here. It's hardly visible. This is just that I've amplified the pixels to show you in this demo, and that's why you see it. Otherwise, on the face of it, nothing is visible at all. This is not programmed with a Meterpreter. It's just a simple calculator thing. So let me pull it off. Let me see if this works. I'll load this in the browser and click it. Now the Firefox canvas is very fast, so the heap spray is going to be pretty quick. I'm going to give it a shot. If it works, if it doesn't work, I'll try it 2 more times. If not, I'll say that okay, my exploit dev skills are useless. Here we go. Attempt 1. Oh, worked. Great. So I prayed to the demo gods enough for this to work. All right. So demos are successful. That is the most critical part of every talk. Your live demos have to go well. All right. Now to the end game. A little bit about delivering this entire stuff. So we saw how to take exploit code, put it in an image steganographically with pixels. We saw how to decode it. We saw how to pack the decoder in the same image as a polyglot. We saw how to do this with JPEG and PNG. These are the 2 most popular image formats on the web. And I believe they'll be the 2 most popular image formats on the web for a very long time. Animated GIF is the 3rd image format getting more popular, and GIF stuff is really trivial to do. It's been done before. About delivering this exploit. How do you deliver this exploit and make it trigger in a browser automatically? There's a few things when it comes to exploration of HTTP, we can get a few advantage with concepts like content sniffing, with cache control, and with really clever CSS. When I demoed these things, you may have noticed that the files had no extension. I did not name them as .jpeg, .png, I just left them as they were. This is an example of forcing the browser to detect what type of content it is simply by inspecting the file. And this is a diagram from Michael Zalewski's fantastic book, the Browser Security Handbook and the Tangled Web, where he's given the criteria when the browsers are forced to perform content sniffing. How does a browser know whether a data stream is HTML or JPEG or PNG or whatever it is? First rule, look at the content type from the HTTP response header. If the content type says text HTML, render it as HTML, done. If there is no content type, the second rule is look at the extension. If the extension is .html, .png, .jpg, treat it that way. In the absence of the extension, just make a guess. You look at the first few bytes. If you see HTML code, run it as HTML. You see JPEG code, run it as JPEG. And in this case, what happens is both Firefox and IE fail to load these data blobs as JPEG or PNG. They instead load them as HTML. And when they're loaded as HTML, they just run. If you are an attacker and you have control of the web server that you're serving it from, you can serve a JPEG file with content type text HTML, and it will force the browser to interpret the JPEG as HTML and run it. Crazy, but it's true. And browsers are notorious for being the most friendliest pieces of programs on the internet. They will let anyone walk in the door and render themselves in your house. That's what browsers do. So that's why we're here year after year at conferences like Black Hat talking about this. And that's why I have a job. The other cool thing about this is a data forensics and incident response nightmare, is how to go back to the past or back to the future with payloads. So imagine a scenario like this. Now we're playing around with a cache header. I send you an image today. It's a valid image. And I set the content expiry 6 months into the future. Now the image will be cached on your disk, sitting there. The next time a browser makes a request for the image, it's not going to make a request on the wire. It's just going to make a cache request and pull it out from disk. So I send you an image today. The exploit code is sitting there in your hard disk doing nothing. 6 months later, I will send you the decoder stuff. It'll pull up the same image. No transaction has occurred on the wire, and you'll get owned. Now, let us say you're one of these big companies, got a lot of venture funding, who just basically rolls the dice and says it's China that did it. They come and do incident response. They say, okay, let's look at the sniffers, let's look at everything. You're not going to find anything. How far back does your sniffer window go? How many packets have you kept to be able to figure out where the hell did this come from? So this is another crazy trick you can play. As far as detection stuff goes, I ran it on a private version of VirusTotal. I'll never put it on VirusTotal because then Google will get it. And all the AV engines flagged off, yes, okay, good to go. So this technique works. This technique is still undetectable. Even though it's very primitive steganography, it flies under the radar because we are not treating images as a suspicious entity. I want to make a different point though. First, let me just tell you where to get the stuff from. If you want the Stegospolit Toolkit, refer to this beautiful publication called POC or GTFO. It is in issue number 8. The Stegospolit Toolkit is embedded in the PDF of POC or GTFO. So you take the PDF, unzip the PDF, you get a set of tools. There's a PNG file in that list. Rename the PNG as HTML, load it in your browser, click on the lion, it'll drop a 7Z file onto your desktop. And that is a Stegospolit Toolkit. So that's how you get it. If you don't know how to do it, you don't want to play with Stegospolit because you might just burn yourself. Read the paper. It's on stegospolit.info and also on POC or GTFO. It explains you everything, how it's done in full detail. And now for the conclusions. As far as offensive stuff goes, you can see plenty of conclusions right here. I don't even need to enumerate what can go on. But someone made a very, very nice observation that protocol spanning, syntax-based, generalized exploit methodologies are the new black. We are going to see such examples of combined packages coming our way as far as the next wave of exploit delivery goes. And we need to be prepared about this. As far as the defense stuff goes, now I mentioned to you the challenges about defense. I want to step back a little bit and be a little more inspired from Haroon's keynote this morning. Several people have asked me, okay, so how do we patch Stegospolit, or how do we fix Stegospolit? Well, guess what? It's the wrong question to ask. I don't want to say that, oh, you can't patch it, you can't fix it, it's going to own you forever, haha. But this is the wrong question to ask. The question to ask is, why do these things work? Why does a browser allow HTML embedded in JPEG to be loaded and run? Browsers need to wake up, browser vendors need to wake up, and the W3C needs to wake up. Browsers need to be strict. We have enough of front page tolerance for 2 decades. It's time that browsers got their act together, like compilers. If you miss a single semicolon in a compiler, no exe file. You just deal with it. Have you heard a programmer complaining and throwing rocks at the compiler saying that, damn it, why doesn't it just accept my semicolon and move on? No, we're trained that, okay, compilers are strict creatures. You want your executable code, play nice with them and they'll give you your stuff. Browsers are like laid back, useless slobs. You give them anything and they'll render stuff. Now that's not how it's supposed to work. It's time browsers got really strict. The W3C has to get up and enforce this. Very much like the Wi-Fi Alliance. Back in 2000, every vendor was trying to break the 802.11 protocol spec and create their own high-speed PCMCIA cards. Well, out comes the Wi-Fi Alliance and says that don't buy a PCMCIA card which does not have the Wi-Fi logo stamped on it. Don't buy a router which doesn't have the Wi-Fi logo stamped on it. And consumers started asking for compliance and conformance to the standard. This is what needs to be done with browsers, finally. For heaven's sake, stop interpreting any rubbish. Why does JavaScript have to be symbols and interpreted like this? It's just this emoji in there and whatnot. Why does this thing have to work in the first place? Get it right and I won't be on stage again. That's what you guys need to do. So with this, well, I have a few greets to my friends. This is the entrance of my house with a few years ago, the Rangoli done. A special thanks to a few friends, Michael Zalewski and Jay Albertini. He's a polyglot master. Dr. Mario Heidrich for a lot of inspiration on clever JavaScript. POC or GTFO guys. Level 2 Luxembourg for giving me the space to write this. Black Hat for bringing me here again and again. With this, I am done. We have some time for question and answers. If we run out of time, I'll be out in the hall. Yes, sir. Your question.
Actually, I have to. So have you ever made a study how many of these services that are offering image hosting, like I don't know, or many funny sites like 9gag or encode or whatever, what are they do re-encoding in their services? Because I can already see another scenario. I upload a picture on a funny website and then I run the exploit referencing that image.
So question is how many websites, like have I done a survey of image hosting sites where they re-encode the image or not? Quick answer, no, I've not done a complete survey. I've done a bit of hunt and peck. I have tried very successfully with image hosting services that use Amazon S3 as a backend. A lot of these services will use the S3 file services. And if you upload an image and get the s3.amazon aws.whatever, the whole URL with the GUID, and just send that URL and somebody opens it up as a direct link, Amazon does not serve any funny headers or any control headers. It just lets it go as is and it works. I do know that Facebook re-encodes the images. I do know that Google re-encodes the images. I haven't really been a purveyor of 9gag for a long time. I use my own funny clip art now. But I need to check that. That is like work in progress. I'd be happy if you test this out and give me inputs. We add some more stuff in the Stegospolit paper. Your next question.
I was wondering, how do you know that when you're encoding JPEGs, that eventually the pixels converge? Do you have like a proof for this?
There is so how do I know that the pixels converge? Do I have a mathematical proof for this? My mathematics is very weak. I have a loose proof for this, is that after 2 attempts, if the number of pixels reduces exponentially, if you like start seeing an exponential decline of the error, then you will hope that the image will converge. If the decline is not exponential, if it is sort of, I don't know the term for it, somewhere between exponential and linear, I guess it will be called polynomial. If it is somewhere in that region, then it will not converge and it'll screw everything up. For me, I just use trial and error. The larger the image is, the better are your chances for convergence. I've used an 800 by 600 image, but if you use like 1280 by 850, you can spread apart the pixels in a larger grid. Like I've used 3 by 3 grids, but you use 8 by 8 grids, you get really fast convergence. Because JPEG encodes 8 blocks at a time, 8 by 8 blocks at a time. 2 minutes left for more questions. Yes, sir.
Are you able to also have the exploit working for an image which is embedded into an HTML page?
Am I able to make the exploit work for an image embedded in the HTML page? No. If I were to be able to do that, I'll be very rich. I won't be standing here. But that'll be the exploit of doom. That'll be the end of the world, which would be great. In fact, like be the right thing to reboot the web. Like just overhaul the damn thing once and for all. But no, it does not work, because when it is an image tag, it directly goes to the image decoder libraries. And for that, you need a PNG exploit or JPEG exploit or something. Yes?
So how browser interprets the JavaScript code? I guess that's picked up by the extensions like Script, for instance.
So, okay, how does a browser interpret the JavaScript code in the presence of something like NoScript? Yes. Well, in the presence of NoScript, you just don't get JavaScript running unless you allow that domain. So if it is a domain that you allow, then you get JavaScript running from that domain. This is inline JavaScript. Somebody pointed out that if you use content security policy, inline JavaScript is disabled. So in that case, you take the JavaScript and pack it separately and use a script source equals hash, which re-reference the polyglot as the JavaScript again. And you can do that. There's some mention of it in the paper. But yeah, in the light of NoScript and all, it's basically just going to stop JavaScript like it'll stop any other JavaScript. We're done. Thank you very much, ladies and gentlemen, for your time and attention. I'll be around outside. Have a good day.